Hi everybody. I'm going to explain today in this lecture nodal voltage analysis. Nodal voltage analysis will help us to find the value of the voltage at any node in electric circuit, like here node 1, node 2. The voltage will try to find V1 and V2 using this method. That's what we're going to learn today. I put in the second slides the steps you are going to follow to apply this technique to find the voltage, but I'm not going to read it for you because wasting time. Let me just implement it to one example. Before we apply this method to an electric circuit, I'd just like to review with you two concepts. The first concept is the Ohm's law. If you have a resistor R1 and connected between two nodes A, B, the voltage at node A is plus 8 voltage and the second one plus 5 voltage. So the voltage at A is higher than the voltage at B. So the current will flow from point A to point B in this direction because the current always flow from higher voltage to lower voltage. How to calculate the current? We'll say VA minus VB divided by R1. VA is equal 8, VB is equal 5. The resistance is assumed to be 10 ohm, so it will be 8 minus 5 over 10.3 ampere. Okay, so that will be the current direction and the current magnitude, 300 milliampere. I'd like to introduce you, another parameter called G. G is the opposite of 1R. If R is the resistance, so G will be the opposite of it, will be conductance. So you divide it 1 over R, 1 over 10 will be 0.1. And sometimes they use the unit like that, or they call it Siemens. That is. The second concept, the Kirchhoff current law, we had it before, but just I'd like to review because you're going to use it in this technique. So if you have point here or node, you will the current I1, 2, 3, 4, 5. There are some currents are input and some are output. If we are considering the input, so it will be I1 plus I2, and that would be minus I3, minus I4, minus I5. Because they are not input, they are output to give it negative signs. The total will be equal to 0. If you are considered the input equal the output, so the input I1 plus I2 equal the output I3 plus I4 plus I5. That's the concept that we explained in last lecture. Now let's go to the first example. The first example here, we have the circuit consists of two current source, 5 ampere, 10 ampere, and 3 resistors. We want to find the voltage at each node. The first step, we're supposed to calculate the number of the nodes. How many nodes do we have here? We have 1 here, 1, 2, 3. Okay, so we have 3 nodes. Second step, we have to choose one node as a reference. Usually we use this one, the one connected to the ground, and we give it 0. So this is node 0, node 1, node 2. So actually we have now 2 nodes that we try to find the voltage. So we'll say that we want to find V1 and V2. They are unknown and want to find it uses this node voltage analysis. Okay, how we start to doing that? Well, we'll start to apply Kirchhoff current law at each node. We'll apply it at node 1. We have 2 nodes, node 1 and node 2. So we are going to apply. First, we'll say, okay, the voltage at 1 will assume it's equal to V1. And at 2, the voltage is equal V2. What about the current? We don't see any current here. Okay. We are going to assume the current, but let's have just like a gentleman agreement that any current will take it in the clockwise direction. Okay? Clockwise direction. So if you want to assume current in this 2 ohm resistance, if you are talking about clockwise direction, are you going to make it up or down? It will be up, directed upward, and that's one current. And this one, it will be in this direction, and this current will be in this direction. Do you have any other elements? No. The current source already 10 ampere, it means it's going inside here, and 5 ampere coming out here, and node 1 will be 5 ampere going in here. So, the all direction now of the currents are there. We know 2 current sources. We know the magnitude of 2 current sources, 10 ampere and 5 ampere. What about the rest? This one, you don't know it. Okay, you'll just give it any symbol, like give it I1, I2, I3, I4, whatever you wanna do. Okay, well, let's say that you're going to say that this current is I1 and this current in 4 ohm is I2 and I3. Okay, you don't have to assume here I4 or I5 because you know it's 10 ampere. Now we are going to apply the Kirchhoff current law at node 1. Okay, when you make it node 1, Kirchhoff current law applied at node 1. Oh, I got to have nice handwriting. You will see here this node. I mean, I will try to make it here. There is current I1 and current coming out I2 and coming in here the 5 ampere. So the first equation is I1 is input, 5 is input, I2 is output. It will be equal 0. So that will be equation number 1. Now we'll go for node 2. For node 2 here, I mean, let's just sketch it. When you get used to it, you don't have to make the sketch I'm doing now. Just, I mean, because it's the first time. This current input is 10 ampere. And there is coming out here 5 ampere. And in this direction, it's input because I mean it's I2 is going in. I2 and I3 coming out. So let's write the equations. I2 is input, so we I2 positive, and 10 ampere is input. I3 is output, and 5 is output. That's equation number 2. We may simplify it. We can say I2 minus I3, 10 and minus 5 will be plus 5 is equal 0. That's equation number 2. So we did this step that we wrote the Kirchhoff current law for each node. Now we'll go for the step after that. We will we'll write Ohm's law okay at each branch. Okay, let's look at this branch first. This branch also, I will say, just let's make it like that. It's 2 ohm. Okay, and the voltage here is 0. Okay, I mean, not to confuse you, I'm going to sketch it exactly as this. If it's a vertical, I will write it as a vertical. Okay, that's 2 ohm. This point connected to the reference, and the reference, we assume it is 0 voltage because it's connected to the ground. That's always 0 voltage. The voltage here at this point, we assume it's equal to V1. We don't know it. And the current going upward like that, I1. So you write Ohm's law as I explained in the last slide. I1 is equal, okay, 0 minus V1, because it's going from this direction, divided by 2 ohm. So, because Ohm's law said, I mean, where is the direction of the current? Then you will see this voltage minus this voltage. So you can say it's equal minus V1 over 2. That's equation number 3. I1 is equal minus V1 over 2. Equation number 3. Let's take the other resistance, 4 ohm, this branch. Okay, 4 ohm. And 4 ohm, you have here V1, you have here V2. V1, V2, and the current, we assume in this direction, what we call it I2. Now we don't worry about which one is bigger or smaller. I mean, this is your assumption. So according to your assumption, you write your equation. I2 is moving from the direction of V1 minus V2 divided by 4. And that's equation number 4. Okay, so what's left? 6 ohm. All right, 6 ohm. Can you write it directly? You have here V2 and you have here 0, and going this direction will be V2 minus 0 over 6. That's I3. I3 is equal V2 minus 0 over 6. That's equation number 5. So now we have two sets of equation. Equation, you got it from Kirchhoff current law, 2 equations, and you got 3 equations from Ohm's law. So what you're supposed to do, you are mainly using Kirchhoff current law, these 2 equations. Because we have 2 nodes, 2 voltages, V1 and V2 are the unknown voltages. So that's your main equation. That's very important. Why I'm saying that? Because you got to substitute by these 3 equations in the 2 equations. Some people do mistakes, they substitute by these 2 equations in the 3. No, we substitute by the equation. We got it from Ohm's law in Kirchhoff current law. Kirchhoff current law here, or Kirchhoff current equations, they are the main equations for that. So I1 plus 5 minus I2, I will substitute by I1 minus V1 over 2, I put it there, and I2 by V1 minus V2 over 4. Okay, I will just make a copy of it. I will write it down first in a piece of paper, then write it, because I mean I will, if I flip this page, I will not be able to see it, but I will write. You can check when you review. That's equation number 1, and the equation, I'm going to equation I1 and I2. I1 is equal minus V1 over 2, and I2 is equal V1 minus V2 over 4. Okay, let's go to the just empty space here. I will write again for you not to forget. I1 plus 5 minus I2 equals 0. That was equation number 1. I'm going to substitute by the value of I1 by Ohm's law. That was in minus V1 over 2 plus 5 minus I2, which is V1 minus V2 over 4. I advise you to use bracket because there are many mistakes for using the negative signs here. So it's better just to put bracket. Now let's simplify. I'd like to have a common denominator. So that's 2, 4. I multiply the whole equation by 4. Multiply by 4. So what you get if you multiply by 4, you have minus 2V1. 4 times 5 is equal 20. 4 times 4 is cancelled. So what's left? What inside the bracket? V1 minus V2 equals 0. Simplify. Minus 2V1 plus 20 minus V1 plus V2 is equal 0. Collect the terms together. Minus 2V1 and V2, minus 2V1 and minus V1, that's equal to minus 3V1. You have only V2 left, and 20 on the other side will be minus 20. Multiply by negative sign, so you have 3V1 minus V2 equal 20. That will have equation, let's call it equation A. All right. Now we want to go for I have to go back, second page. So this equation I'll write on a piece of paper. I2 is equal minus 3 plus 5 equals 0. I need I2 and I3. We have I2 and I3 here. I3 is equal to V2 over 6. So I will go back here. Just let's make it a different color. I'll write equation number 2. I2 minus I3 plus 5 equals 0. That was equation number 2. I substitute from Ohm's law. I2 is equal V1 minus V2 over 4 minus I3. I3 is equal V2 over 6 plus 5 equals 0. Again, I try to find something common to multiply. I will multiply the whole equation by 12. You multiply 12 here by 1 over 4, you get 3. So you have 3 V1 minus V2 minus 6 times 12 will be 2 V2. 12 times 50 times 5, I'm sorry, equals 60, equal 0. Now simplify. 3V1 minus 3V2 minus 2V2 plus 60 equals 0. Collect the term, you have 3V1, nothing else, so you have 3V1. And V2, you have minus 3V2 minus 2 will be minus 5V2 plus 60 equals 0. I will go here and continue. I have 3V1 minus 5V2 equal minus 60. Please, try to solve this one, see if I did any mistake or something. But the method is very clear. Now that's equation B. You solve these two equations simultaneously to find the values for V1 and V2. Just to remind you, there are many ways to solve this equation. You may solve it simultaneously, but when you have big circuits has like 3, 4, 5 nodes, you will have 5 equations. It would be hard to solve it like that. So may use matrix, inverse of matrix, or Cramer's rule if you got this before. If you have any problem about these methods, you don't understand it, just tell me and I'll make a special lecture how to solve equations like more than 2 variables. Okay, so anyway, that's easy. I will just go ahead and solve this equation simultaneously. That's A. I will put it here, 3 V1 minus V2 is equal to 20. The second equation, 3 V1 minus 5 V2 equal minus 60. That's 7 positive. So I multiplied by negative sign, the one on the bottom. So I've been negative, positive, positive. You add 3 minus 3 be 0 plus 5 V2 minus would be like 4 V2, 80. So V2 is equal 20 volt. And then you can substitute to find V1. You will substitute, you'll find V1 is equal to 13.33 voltage. And you can check by yourself. Okay, great. So that was the first example. Easy and simple for this method. Okay. We have other cases. You got, just to look what we did first. In this example, we have current sources. So you can say node voltage analysis or node method is really easy and simple when you have current sources. So this is the normal case. I'm going to take other cases. What about if you have voltage source? What you will do? Okay, when you have voltage source, it's a little bit different. It will be different than when we did, slight different. And I explain in these steps what you will do. Okay, as I said in the first case, it's not good to read the steps and then go implement it because it doesn't make any sense. But I will go ahead and do one example here. In this example, you will observe that you have voltage source, not current source. How many nodes do you have? You have 0, 1, 2, 3. You got n is equal 4 nodes, but there is one reference. You're going to ground it. So you have 1, 2, 3 nodes. So you have you will say that you need to find V1 and V2 and V3. But this is the difference. When you have voltage source connected to the node, so why you want to find V1? V1 is already known. Why? Because if you connect node 1 to the ground and you put voltmeter, this volt between 1 and 0 at node 1, it's the same as the battery. So this one will give you 12 volt. So actually V1 is not. It's 12 volt. We call this dependent node. What does it mean dependent knob? Means the voltage if this knob depend on the voltage source connected to it. So you do not have to find equation for V1 because the value it's known 12 volt. So what's left for you? Not 2 and not 3. Okay, so just let's move this voltmeter and let's stress on the V1. We'll say that it's equal here to 12 volt. It's known. All right. So that's the first step. That's the difference. You look for the volt source and now what you will do? You will say now the unknown value that you want to solve for it. It's V2 and V3. As you do in anything, you got to assume the current as we think clockwise direction in each branch. So there is current here. It will be in this direction. Clockwise direction would be one going down. If you are moving, so it will be in this direction. The current will be in this direction, and here if you are moving like that, so it will be in this direction. Okay. Now we'll just give it, we'll name these currents. Well, we'll call this I1. We'll call this I2. This one, 2. And we'll call this one I3, I4. This one, the same current, I4. Just, make sure, I5. So you got from I1 to I5. So that's, the step that to do that. Okay. Try to remember the sequence that I'm using to solve this problem. And then you go back and read the steps. After that, what you're supposed to do, the most important thing in knot equation is to write Kirchhoff current law. That's, the most important thing. Okay. Well, now we ask yourself, how many Kirchhoff current law equations you are going to write? Easy question. The number of Kirchhoff current law that you are using, it's equal to the number of independent knots. You have only 2 independent knots, 2 and 3. V2 and V3. Again, I will remind you, what about this knot? It is not independent, it is dependent, and the value is known, so you don't have to write equation for it. Okay, now let's write equation for knot 2. For knot 2 here, let's look at the current in and out. I1 is in, positive. I3 is out, negative. I2 is out, negative. Do you have other current here? No, 3 current. Equal 0. That's equation number 1. Now write for knot 3. That's knot 3. I4 is in, positive. What about I2? I2 is in, positive. And I5 is out, minus I5, equal 0. That's it. So these are the 2 main equations that you want to solve. But you cannot solve it because you have many unknowns. I1, I2, I3, I5, I4. You got many unknowns here. You got 5 unknowns. So what will help you to solve these 2 equations? You will just write Ohm's law, right? Ohm's law. I will apply it, okay, for the branches, like we did last example. Okay, we'll be I1 first. You see, I1. I1 is equal this voltage minus voltage over R2, 22 kilo ohm. My advice to you, when you have the whole resistance in kilo ohm or majority kilo ohm, leave it as it is in kilo ohm, and your answer will not be in ampere, will be in milliampere. That's a very normal practice in electric circuits. So you have V1, which is equal to 12 volt minus V2 and over 22 kilo ohm. We know it's 20 kilo ohm. You can write this not to forget. So that's equation number 3. We need to find I2. I2 is equal this voltage minus this voltage over 7.5 kilo ohm. So I2 is equal V2 minus V3 over 7.5 kilo. That's equation 4. Equation 5. I'm sorry, not question 5. Yes, it will be I3. Where is I3? Okay, that's I3. V2 minus 0, because the reference node, always the voltage at reference node is equal 0. So it would be V2 minus 0, or V2 over 8.2 kilo. That's equation number 5. I4. That's I4, yes. Let's just slide I4. This voltage minus this voltage over 15. This voltage is 12. And this voltage connected to 3V3 over the resistance is equal 15 kilo ohm. That's equation number 6. Equation number 5. Number 7. I5. This voltage minus this voltage over this. This is V3 minus 0. Okay, and have to write over the resistance 10 kilo ohm. That's equation number 7. So now, in this equation, I1, I3, I2, you substitute from here equation. And the equation 2, the same thing. Let's substitute. When you substitute, you will get the following equations. Okay. From equation 1, after substitution, I will just give you the result and you can check by yourself. That will be good practice for you. You will find equation 1, it will be something like that. Minus 1 over 22 minus 1 over 7.5 minus 1 over 8.2, all this multiplied by V2, plus 1 over 7.5 V3 equal minus 20 over 22. Try to check, because it's just substitution. There's no idea in it. It's just the same thing. Equation number 2, after substituting, I got that 1 over 7.5 minus 1 over 10 V2 plus minus 1 over 15 minus 1 over 7.5 V3 is equal minus 12 over 15. So we got two equations in two unknown, V2 and V3. You solve it by matrix, by simultaneously, whatever, but you have first simplify this and make sure that you did the right substitution. I'll give you the answer now to check your work. V2, the answer will be equal to 3.87 voltage, and V3 will be equal to 4.646 voltage. Okay, let's agree about something. If you have any number in the homework, quiz, or test, and only decimal, you have so use 3 digit behind the decimal point. Okay, if it's 0, if it's this one 0, if this one number like 1, 2 or something, there is a number here, you may have to decimal number after decimal point. So just we'll agree about this accuracy. So that will be the answer, and try to check your answer, work it out. That will be good practice for you. Okay, now I'm going to explain really some kind of different case. Sometimes you have the voltage not connected to the common node or not connected to the ground. Sometimes the voltage source is connected between two nodes in the middle of the circuit. So what you call this? We call this, we make something called supernode. Supernode, it's formed by enclosing voltage source between two non-reference nodes. Let me explain it again. This one is not supernode. Why? Because the voltage source connected between node and another node, and one of them is reference node. This is a reference node. But this voltage source connected between node 2 and node 3. Neither one of them is reference node. So what we'll do? We'll do simply, we make these two nodes one node, and we call it super node. That's why we call it super node. And we treat it as a one node. See, I mean, you covered like one node. And I will show you in this example that, I mean, let's, I mean, undo what we did. I darked, right? I mean, it's here, I made it here. But you keep the voltage as they were. For example, it's on one node, but I2 coming out here and I1 going in the node, so you make it as it is, but keep the voltage. If the voltage of this point V2, so that's V2, and you have the other side of the point, the super node, I3 coming out, and the V on this side V3, okay, you have another current here coming I4 inside the node, and the voltage here V3. So it will be like a strange node, different the other node, because usually the node has only one voltage, but here the node has different voltage. It depends on its side that you're looking for. For example, this node or super node here, it has V2 and V3. Okay, but it's still, when you deal with it as a super node, the currents in and out will follow Kirchhoff current law. For example, here, when you look at the current, what's input to this super node? I1 is input, I4 is input. So I1 plus I4 is equal I2 plus I3. Okay, you deal with it as a node. Super node is a node. What's different? Super node, since it's a node, it follows Kirchhoff current law. And because it's super, it will have different voltage in any side. And when you apply, for example, I mean here I1, this voltage minus this voltage over up, the same thing with it. So be V1 minus V2 over 2 ohm. You want to find I2 to put it in this here, it will be in this direction, be V2 minus 0 over 8. I4 will be voltage V1 minus V3 over 4. I3 V3 minus 0 over 6 ohm, and substitute in the equation. It's the same thing after that. The only concept, just, I mean, it's a weird thing, the super node. Follow the current law as Kirchhoff, but the voltage will be different. The not super node, it has only one voltage, like this one, it has only V1. That's it. Okay. Let's take one example. That will be our last example. I mean, just, I'm trying to expose to you different cases, so when you start do your homework, you will have experience for dealing with different situations. Okay, now that we have here this problem and we try to solve it. Okay, in this example, let's change the pen. When you look at we have how many nodes here? 1, 2, 3. Because this is the ground, all right? So you got node 1, node 2. But there is something here. There is a voltage source, and this voltage source, you don't have one of them reference. The node 1, node 2, they are not reference. They are not the ground. So you can collect these 2 points together, squeeze it to make a super node. Let me just, I mean, this one will be a super node. Super node, that's a node, one node. If you want to sketch it, I can sketch it in a way. I will make the super node like, I mean, thick node to make it different. But the current, let's see the current. let's say that the current here I1, assume the current here I2, and assume the current in this one I3. Anything else? Somebody will ask, well, you didn't assume the current in. I can assume it's 2 ampere. It's 2 ampere coming in, and here the same thing, 7 ampere coming out. You don't assume. I assume the current in the one doesn't have current source. Then you ask me about what's in the middle. No, it's supernode. خلاص. It's already covered. You don't look at it. Just squeeze it. That's it. Okay, and if you look at this as not, I will just mark it by marker here, and let's make this nice color. Okay. Oops. Not to look at. So this is a supernode. What's coming in? 2 ampere. Coming here, I1. But once you have resistance, you got to know the voltage of it. What the voltage here? V1. Here 0. Ground. What else? You don't look inside the supernode. No. Prohibited. I2 coming out. But there is a resistance. You write I2. What is the voltage here? V2. Write V2. And here is 0. You have current coming out 7 ampere. Not connected to resistance, so just write arrow like that, 7 ampere. What's coming here? Oh, that's, a very interesting thing, because you find there is one coming here, I3. I know there is resistance, but I will show you something interesting. And this one is coming here, I3, resistance. So actually, when you have the same branch coming in and out, they will cancel each other. So what you do, don't do it. Because if you do it and you add them, be 0. So why are you wasting your time? Do you see what I mean? It's coming out I3. It's coming in I3. So it come out and come in again. So when you add it one time by positive sign, negative sign, it will cancel. So any branch coming in and out or parallel with the voltage source, just delete it. Okay. Now, let's write the equation here. For what I'm doing, I'm writing Kirchhoff current law. I have only one node. So 2 is input. I1 is output. I2 is output. 7 is output is equal 0. So I have minus I1 minus I2 minus 5 is equal 0. I just make it I1 plus I2, okay, is equal minus 5. I have one equation. I have one node. It's a very simple circuit. But I want to express I1 and I2. Okay. I1 I don't take a big space here. I1, okay, different color. Because just many equations. I1 is from this branch. It's going in this direction. So be V1 minus 0, yani V1 divided by the resistance here, which is 2 ohm. Alright. And I2 V2 minus 0 over 4 ohm. Substitute in this equation I1 V1 over 2, I2 I forgot to put here V2 over 4 is equal minus 5. Multiply by 4 the whole equation, so you have 2V1 plus V2 equal minus 20. That's one equation. True. You need another equation. Okay. Can you tell me what the other equation it will help you? Okay. All right. Let us now erase this one. Oh. it will help you now after you do one equation using Kirchhoff current law. Now erase this one and see what is inside. The supernode will give you relationship between V1 and V2. I will just do it here. Positive, negative, and the value is equal to 2 voltage. And here you have V2. Let me do it like voltage source. I'll write it V2 because they have the ground, you know. V2 measured from here, this point to the ground, 0. And V1, that's V1 connected to the ground. Okay, so let me just do it in the other page to make it clear. All right, so now you have voltage source to voltage. You got V2 and V1. V1, I just make it like that. And V2 like that. Maybe somebody will ask why you make the positive up and negative, because I mean V1, when you say V1 minus 0, so I mean your reference is 0, so it'll be higher than the 0. The same thing for V2. Now I mean you want to find the relationship between V1 and V2. Use Kirchhoff voltage law. If you remember V1, the positive connected to the negative, so it will be plus, you're in series, 2V. The positive connected to the positive would be minus, V2 equals 0. So what is the relationship here between V1 and V2? You can say that V1 is equal V2 minus 2 voltage. Okay, and you go, that's the equation that you have, 2V1 plus V2 is equal minus 20. So 2V1 plus V2 is equal minus 20. And you have V1 is equal V2 minus 2. So you have to replace it by V2 minus 2 plus V2 is equal 20. 2V2 minus 4 plus V2 equal 20. 2 and 1 is equal 3. 3V2. 4 in the other direction. So V2 equal 24 over 3 is equal 8 voltage. So you got the value for V2. Okay. Check the answer of this one, because maybe there's a 2V2 minus 4, because I mean maybe we did some mistake in the calculation or something. 3V2, 4 go in the direction. So please check this one. And after you find V2, V1, you substitute the equation, find V1. So actually, supernode is not a big deal. Okay, deal with it as one point, do your Kirchhoff current law, and then after, in the end, you just release it and find the relationship between the two nodes. Okay, that was, I mean, the thing. I left for you here some problems to try. Okay, and then we can discuss in the lecture. So make sure, if you can, I give you the answer. So if you can solve it, it means you understand. We can go to harder problems. Okay, I hope that you enjoyed, and I wish you good luck. Okay, bye.